Today we're going to learn about similarity and dimensionality change. If you look at this says A is similar to B, and it does tell me that one set of sides that are corresponding have a value. From this, I can get the scale factor, or the length ratio is 9 to 6, which reduces down to 3 to 2. That's my actual length ratio, and your length ratio, once you've reduced it, turns into your scale factor. So my scale factor is actually 3 to 2. Now what does this tell me? This tells me that I had to take and multiply the side 6 on triangle A by that amount to get the corresponding side on B of 9. So now I can solve for all the missing sides. So 8 times 3 over 2 would give me 12. And then 10 times 3 over 2 would give me 15. And then 12 times 3 over 2 would give me 18. So scale factor ratio is just a ratio that tells you you're going to multiply this side by this much to get the corresponding side. Scale factor is used for length only. Okay? Scale factor is used for length and for perimeter. Now let's talk about the area ratios. So if I found the area triangle A, it would be 8 times 6 divided by 2, which is simply 24. The area of triangle B would simply be 9 times 12 divided by 2, which gives me 54. So my actual area ratio is 54 to 24. But that's not my area ratio. My area ratio is actually the actual ratio simplified. So if I look at 54 over 24, I know they're both divisible by 6. So I know that if I divide both of those by 6, it would come out to be 9 over 4. That is my area ratio, 9 over 4. Now let's talk volume. To find the volume of the prism A, I do area of the base, 24, times height of my prism, 12, which is 288. Then I'd calculate the volume of the prism B, which would be 54 times 18, which is 972. So my actual volume ratio is 972 to 288. But to get my volume ratio, the actual ratio itself, I would reduce that down by figuring out what they're both divisible by, which I believe is 36. But a lot of calculators nowadays, if you punch this in as a fraction, they will reduce it for you, and it reduces down to 27 over 8. Now, if you take a look at your scale factor ratio and your area ratio, you'll notice that all you did to your scale factor ratio was square it. It's squared because you are increasing both of your sides. You are multiplying both of your sides by the ratio you increased it by. Same thing for volume, except it's no longer squared, it's now cubed. So I cubed my scale factor to get my volume ratio because I'm increasing all three dimensions by the same factor. So now let's see where these scale factors come into play. If I have two similar solids with a scale factor of 1 to 5, so my scale factor is 1 to 5. If the surface area of the smaller figure is 24 units squared, what is the surface area of the larger figure? I can't use my scale factor in my proportion here because scale factor only deals with sides and length of sides. It does not deal with area. So I need to convert this into my area ratio. To convert it into my area ratio, I simply take that scale factor and square it. And it would turn into 1 over 25. Now, they told me the smaller figure is 24. Well, 1 is smaller than 25, so 24 goes on the top, and my unknown, which is what I'm trying to find, is x on the bottom. Now I have a proportion, and I just cross multiply and divide. So I would get that the larger figure's surface area is 600 units squared. Let's try another example. Two similar figures have surface areas of 125 and 20. If the larger figure has a perimeter of 16 units, what is the perimeter of the smaller figure? Alright, they gave me an actual area ratio. The first thing I need to do with this ratio is to make sure it's simplified completely. And it's not, because both of these are divisible by 5. So I need to reduce it down. If I divide both of those by 5, it becomes 25 over 4. This is my area ratio. Okay. 25 over 4. But I don't need that because I'm talking perimeter. Perimeter is length. So I need to go down to my normal scale factor ratio. And to do that, I square root my area ratio. And that becomes 5 over 2. Now I can set up my proportion, and they tell me the larger figure, it has the perimeter of 16. 5 is larger than 2, so 16 is on the top. My unknown is on the bottom. I cross multiply 2 times 16, divide by 5, and come up that the smaller figure's perimeter is 6.4 units. Just remember, when you're given scale factor, if they want area, you square it. If they want volume, you cube it. If you're given volume ratio, then you cube root it to get your scale factor ratio. And if they want area from there, then you square it. It all deals with area squared, volume cubed.